I'm Ms. Awad, and I have 3 of my students joining me today in our 3rd video on igneous textures. So girls, why don't you introduce yourselves?
I'm Rahima.
I'm Christina.
I'm Amina.
Okay, we're going to get started right away. So I have a question for you. Beaker full of water, right? 2 rocks. They're pretty much the same color, right? They're almost the same size. What happens when I put this one in the water? What's it going to do?
Float. It's gonna sink.
Sink?
Let's see.
Float?
I think it'll sink.
You think it'll sink?
Yeah.
Okay. Ready?
Yeah.
Oh, it's sunk.
Like a rock. What happens when I put this one in the water?
It's gonna float.
Float.
Think it's going to float?
Float.
Why is that?
Because this is lighter and it has holes in it.
It has a lot of holes in it.
Okay, it has a lot of holes in it. Good. So we're going to just push these off to the side, and we're going to see if we can figure out what's going on a little bit with this. So in this video, we're going to talk about 2 different textures. We're going to talk about glassy, and we're going to talk about fragmental textures. These are really different from the textures that we talked about in the first 2 videos. In the first 2 videos, we were really talking about lava cooling underneath the earth, underneath the volcano maybe, or cooling at the surface. And now we're going to talk about some different things happening with it. So first of all, for our definitions, do you want to grab the definition of glassy over there? We have a glassy texture. Glassy texture is an igneous rock texture where the crystals don't actually even form because the lava cools and solidifies at such a fast rate. So of all these rocks that I have sitting out here, if I ask you which ones look like they would be glassy, what would you say?
Pick out
Yeah, pick them.
like these
Yeah?
and this one.
Yeah. Okay, so you think these 3 look like they're glassy. Why?
Because they're like shiny looking.
They look shiny. So we're thinking about maybe the physical property from minerals when we talked about lusters and we were talking about glassy luster, right? This glassy is a little bit different. It's not the way the rocks reflect the light. Instead, what it is it's the arrangement of the atoms inside the rock. So in order to make a mineral, one of the properties was that we had to have a set atomic structure. Remember that? Set chemical composition, the set atomic structure. When we look at these glassy rocks, these rocks formed and solidified so fast that the atoms didn't have time to arrange themselves into that set structure. So these rocks actually have no minerals in them. They may have the same elements in them, atoms of the same elements in them that minerals have, but they're not arranged in a pattern to make minerals. Okay? Those are obviously glassy. We see they're shiny, they look like glass. They also have this kind of fracture pattern. It looks kind of like rings that's typical of a glass. There are actually other rocks here, though, that are glassy when you think about the definition of glass being no minerals formed. For example, this one. This is also glassy. There are no minerals in this. Doesn't look shiny like this, but that's a glassy texture. So what do you see in this particular rock, in this one, maybe this one, the one that floated? What did we say was different about those rocks? What do they have? They all have
holes.
They all have holes. Okay. So can we think about how these holes could possibly have formed? The holes are making the rock lighter, light enough that it will float. Here's what happens. When a magma is underneath a volcano inside the earth, before it's erupted, it has gases dissolved in it. Just like if you have a bottle of pop, big 2-liter bottle of pop, and you look at it, there are gases actually dissolved inside that liquid, right? And you know they're there because when you pour the pop out, the bubbles start to come out, right? Exactly the same thing happens with the lava. The lava has gases dissolved in it when it's underground, and when the top comes off and that volcano erupts and this stuff comes out, the gases escape. When the gases escape, they leave behind these bubble holes. Sometimes the bubble holes are big, as in this rock. Sometimes they're much smaller, as in this rock. Look at this guy. Look at these bubble holes here. We have a special name for those bubble holes. So when we are talking about rocks that have bubble holes, these are all glassy texture, but they also have bubble holes that we call vesicles. So these are glassy and vesicular. So vesicular is the texture with small holes that are called vesicles that are formed when the gases escape the lava as it solidifies. Okay? Why do you think the gases want to escape? Why do you think the gases escape when you open a pop bottle?
Because of the pressure.
Yeah, exactly, because of the pressure. So are you increasing the pressure or decreasing the pressure when you open a pop bottle?
Decreasing.
Decreasing it. And when a lava comes out from underground, comes out of the volcano, what do you think is happening to the pressure?
It's decreasing.
It's decreased, yeah. So if you take pressure off of a gas, what do the particles in the gas try to do? Do they try to move away from each other or toward each other?
Move away.
Move away, right? Which is going to cause them to expand, and that's why they make those gas bubbles. Okay? Make sense? All right. So we have our glassy rocks and our glassy vesicular rocks. Okay? What do you think about this one? Does this belong in that category?
No.
I don't think so.
What do you think?
I don't think.
No? Want to lift it? Is it kind of light?
It's a little heavy.
It's a little heavy?
Yeah.
How is it different from this one?
This one looks like it has like other minerals in there,
Okay.
or because it doesn't have holes, but it just has this yellow stuff, which could be some other kind of material or mineral.
Could be. Do we see any holes? Like, look along this edge right here.
You do.
Do you see some really fine holes?
Yeah, they're really tiny though.
And then if you actually tap on this, and I don't think you're going to be able to hear this in the video, but if you tap on it, do you hear how it sort of sounds like a glass?
Yeah.
Mhm.
This is also glassy and vesicular. The vesicles are very small. Okay? So that's glassy and glassy vesicular. We have another category of rocks that we're going to talk about now, which is called fragmental. So when we talk about fragmental, it has the word fragment in it. What does fragment mean? What's a fragment of something? No clue? Not yet? Okay, a fragment is a little piece. Okay, a little piece or a little chunk. Think about a volcano erupting. Get a picture in your head of a volcano erupting. What do you see when the volcano erupts?
The lava exploding out.
Lava exploding out. Do you see anything other than lava?
Fragments, the
Steam.
rocks, like
The smoke.
Steam,
the rocks that come out with it.
the rocks that come out with it. What were you going to say?
I don't know, I was thinking like ash and stuff like that.
And ash. Very good. Okay, so we've got pieces of ash, we've got little fragments of rocks, we've got steam, the gases that are escaping from these rocks. Let's focus on the ash for a minute. What happens to that ash? It gets shot up into the sky, then what happens to it? It comes down, because what goes up must come down, right? So the ash gets shot up into the sky, and it falls down along the flanks or the sides of the volcano. What does it do there? Piles up.
Yeah.
It's like an ash storm instead of a snowstorm. It piles up, and a lot of times, because it just came out of a volcano, it's still pretty hot. So just like on a hot, humid day, and you get your sugar bowl out because you're going to put some sugar in your iced tea, and the sugar's kind of stuck together, the ash that piles up around the bottom of a volcano will stick together. So you get these rocks, which are a little bit hard to identify. Sometimes we can confuse these rocks for being aphanitic. We get these rocks that are actually ash that has stuck together. And these are rocks that we call fragmental because they're little pieces of ash. Now sometimes there are other little chunks of rock that might get pulled into that, like here's a little piece that looks like of gravel that's stuck in there. That would also be fragmental. So you have ash surrounded by maybe some gravel that was already existing there. Okay? So these look different than the glassy rocks. These could have mineral crystals in them that got shot out of a volcano. These don't have mineral crystals. Okay? The last term I want to talk about is pyroclastic. So pyroclastic, what do you think the pyro part means? Any idea? If somebody's a pyromaniac, what do they like?
Fire.
Fire. Okay, so the pyro part is fire, and the clast part is like fragments. It's little pieces. So pyroclastic is an igneous rock that forms from little bits of ash or other materials that are ejected out of a volcano. So these fragmental rocks are also referred to sometimes as pyroclastic. Okay? All right, so we have, what were these over here? Texture?
Glassy.
And these guys.
Also classy.
And what else about them?
That starts with the V.
It starts with a V, exactly.
Vesicular.
Right. And these guys are
Fragmental.
fragmental. Okay, perfect. Questions, girls?
Yeah.
You got it?
Yeah.
All right, thanks for joining me. Take care. Bye.